Hello everybody. I would like to thank you the organizers and express my wish RILEM continue offering to society sound knowledge and research achievements. I'll speak about lime-based mortar past, present and future. As you know, historic masons constitute the greatest maybe part of cultural heritage and have been constructed with lime-based mortar. Which play different functional roles as bending, flooring, plastering, rendering mortars. Here you can see some characteristics of old mortars taken from monuments of Roman, Byzantine and Ottoman period. Mean values for strength, for porosity, for specific gravity, corresponding to binding system. You can see that compressive strength is very low. We can say between 1 and 6 megapascal. Porosity is high, between 20–30%, and specific gravity below 2 in comparison with cement-based mortars. The most often found binding systems were lime pozzolanic component, such as natural pozzolan, brick dust, reactive soil. Later, at the end of 18th century, hydraulic lime and cement, Roman cement started to be used. The monuments protection was, the importance of monuments protection was recognized very early, and principles of restoration were declared in a list of charters widely accepted. Compatibility, retreatability and durability are the principles of restoration. Of course, the particularities of all the structures and lime-based mortars were also recognized. We learn a lot from the failures because of use of inappropriate repair materials. You can see failures at the archaeological site of Dion because they use cement-based mats for rendering. We can see also fluorescence in city walls of Thessaloniki. You can see also cement-based mortars used for pointing, and the materials below of behind of cement-based mortars, bricks and original mortars have been destroyed. Here is a most indicative picture from University of Delft showing that poor lime mortars were insufficiently carbonated and damaged from freeze-thaw, and also very strong cement-based mortars remained stable, but the bricks were destroyed. From 1980 to 2010, large projects were carried out on lime-based mortars on microstructure characteristics, performance, and long-term behavior. Here you can see a indicative list of these projects. During the last 2 decades of 21st century, 3 successful RILEM TCs have been implemented on characterizations of analysis of all mortars, on designing and properties of repair mortars, and reattachment of architectural surfaces. In the frame of these RILEM TCs, much collective knowledge has been produced and published in RILEM reports. Many messages, such as before any repair, a prerequisite is to understand the functional role of the mortar and also the mechanism of deterioration of it. And the priority of any repair mortar is not to disturb the existing structural system, and at the same time be effective and resistant as much as possible to the mechanism of deterioration. It was a great progress in designing repair mortars to define compatibility in technical terms. We found that the most influential parameters were surface feature, composition, strength level, elasticity, porosity, and coefficients of thermal dilation. Here you can see microstructure of two original mortars from Byzantine Ottoman monument and Hagia Sophia Byzantine monument. You can see at the right we have in the matrix many pores and cracks, while in the case of lime pozzolan mortar in Byzantine monument Hagia Sophia, we have more compact matrix and very good interface between matrix and crusted brick. Other parameters influencing repair mortars is, of course, the fineness and reactivity of pozzolanic material may increase considerably early and final strength. Hydraulic component also increases strength. The final strength is reached the maximum at about 90 days age, and the ratio of flexural to compressive strength is higher compared with cement-based mortar. About pore size distribution, here you can see pore size distribution of the old mortar taken from Hagia Sophia, and at right we can see a repair mortar based on the same binding system of composition. In both cases you can see that the most percentage of pores concern the diameter 1 to 0.1 microns and are the same. So there is a proof of compatibility between repair mortar and original one. About the role of aggregates, we can say that the use of coarser aggregates, especially in the case of thick joints, mitigate the drying shrinkage deformations and creep deformations, but at any case these deformations in the case of lime-based mortar are much higher than in the case of cement-based mortar. Curing regime play an important role. If lime pozzolan binding system is cured in a natural curing system or without any moisture, then the strength, the level of strength is very low, while if we properly cured in moisture, then we have adequate strength development at 28 and 90 days. Nowadays, although the lime-based mortars are generally preferred in restoration, and there are regulative frames such as EN 1015 series and CEN TC 346, the quality of restoration works is not adequate. And if you take into account that repair works are more expensive than a new construction, that any repair has a cost for integrity and authenticity of the monuments, and we invest money and we must pursue long service life to depreciate the money we have invested in repairing. It's need to improve and establish an effective system of testing the quality of lime-based mortar and techniques by which they are applied. Here are the most often lime-based binders used and their combination for strength enhancement. We have a calcitic lime, we have a dolomitic lime categories, we have hydraulic lime categories, natural pozzolanic materials, artificial pozzolanic materials used in combination with lime, of course, and also cement, because very often we use ternary binding systems consisting of lime, pozzolan, and dosage of cement. Most regulative frames used do not address the soft nature of lime-based mortar, and measurements are not reliable. Other properties like cracking tendency, for example, is impossible to be measured with existing standards. So the main objective of our TC is to make improvements or modify test methods in order to comply with the nature of lime-based mortar and provide more reliable results. I have summarized some of our work done in the frame of our TC concerning improvements or suggestion of standard methods about curing lime-based mortars, about adhesion, about measuring water absorption, about measuring water vapor permeability, and let's go to another field which is the most difficult, which is the practice in restoration. There are many problems concerning starting from the storage of materials in the limited space of monumental structures, and they must be sheltered, for example, and goes to the problems with curing the repaired masonry walls covered with wet burlaps, and also a necessity to have to weight all the materials because to avoid the bulking of sand and moisture content of them. For application of lime-based mortars, there aren't manual of practice or guidelines addressing the difficulties found when we deal with these soft materials. There aren't widely accepted reliable on-site methods of testing fresh properties of mortars and grouts. Technicians also should be trained to confront particularities of soft lime-based mortar because they are most of them are familiar with cement-based mortars. Here is an example of what we have proposed, slam-type cone in order to find the water demand for adequate workability on site. There are also other particularities having to do, which are important for application. We need specific tools, for example. We need also to compact very well, otherwise we lost up to 50% of the strength and also adhesion. Concerning the future, I can say that the great challenge of next decade seems to be the urgent need to reduce the impact of the construction sector to environment and save natural resources. In the field of restoration, apart from the well-established principles, compatibility, retreatability, and durability, as we say, we must add another principle, which is sustainability in terms of combined environmental protection and socioeconomic effectiveness should be added. Here are the three cycles showing the principles of restoration of the future. Based on statistics, we can say that European economy depends on cultural tourism and produced secondary economic products. Restoration also plays an important role in development of local economies. The preservation of historic structures is closely related to society cohesion and citizen welfare. And of course, as people, as it said very correctly, the values of European communities are enclosed in these live capsules of history and civilization. Here you can see the beauty in Byzantine churches based on the masonry walls and wooden beams. In historic centers of rural cities or in mountainous villages, there is a stock of buildings that need rehabilitation. I think we can revive a lot of new jobs and also give life to these cities. The question is, could the lye-based mortar respond to the green challenge? Of course, yes. We can design greener and more effective lye-based mortars by using local materials, aggregates from the proximity of the restoration, in the proximity of the restoration field. Also local, natural or artificial pozzolanic materials, natural organic additives to improve cracking resistance, recycle phase change materials in order to improve thermal properties, bacteria biofilms with super hydrophobic and antimicrobial and anti-fouling properties to protect monumental surfaces. And also we can produce green biomimetic lime and hydraulic lime. However, to transfer these achievements from laboratory into practice, much collective work is needed. We need criteria for selection materials, simpler quality test methods, testifying the good performance in short and long terms, and proving quantitatively the green dimension of the mortars. It's need to develop lime-based mortars inspired by EPDs. Based on life cycle assessment, life cycle sustainability analysis, and life cycle cost analysis. To succeed in the aforementioned objectives, the existing knowledge in repositories should be enriched and effort for data analysis enhanced. Furthermore, guidelines, monitoring protocols would be applied to ensure the safety of the integrity of monuments from harmful side effects. The combination of the protection of the natural environment and cultural heritage structures is an invaluable entity linked to the necessity of citizens' awareness about safeguarding their property. More intensive multi-level work is needed, with the involvement of local authorities, social media and organizations, education sector, highlighting the economic impact to employment, revival of new jobs, and we need to manage such activities with enthusiasm and imagination. Thank you.